All right, thank you, fellas, for joining. It's Knowledge Engineering 26. What does anyone want to bring up or add in? We'll see who else joins in, but we can continue on Tom's database. We can continue on some of the different topics from Chris and others. We can look at some chapters of the textbook related to knowledge engineering. What does anyone prefer?
Any way you want to go.
Randall, anything?
Um, no particular preferences at this point. I'm in learning
What
mode.
Okay. What about uh a juxtaposition between George, whatever you think is the most relevant figure in the textbook, and this? What figure would or what figures come into play for the overall system knowledge system design?
Um, well, could you go back and show
Yeah.
Tom's figure? I didn't quite catch. Modeling tool. Well, I don't know that there's any kind of direct mapping. The stuff in the book has to do with the description of the knowledge base, its structure and the process by which you capture all the elements that go into the knowledge base. And so I think there are a lot of things in Tom's uh, figure there that are relevant, especially the tool part. But I'd like Tom to tell us a little bit more about the semantic model and what that means. What all is involved in the semantic model? Because in my version, it really is defined by that set theoretic equation, or formula, I should say. And so I'm curious to know more about what's in the semantic model.
Tom?
I'm not sure he can hear us.
Maybe he's frozen. Where's the piece then that is the full equation or full figure of the essence of the systems model? There's some equation with all the variables, right?
Yeah, that's the oh, what is it? Chapter. I can't. I'll have to look it up myself. Um, yeah, it's chapter 4, section. Section 433. What page is that?
Okay.
Yeah, so page 191 shows the basic equation. A system is defined. Oh my goodness. Something happened. This is the first time I've looked at this in the print book itself. Something happened to the notation.
Is it different in the PDF or in print?
Well, it's different in the version that I sent in. All it's missing here is just the braces to demonstrate that it's a
What about
set
this one?
of sets. Huh?
What about this one? Is this the braces that you expected?
Yeah, now that one's okay. So I think I used angle brackets or angle braces, whatever you call them, to
Bracket.
designate a set of sets. Huh.
You define that above, or you used it only here?
Well, just there.
Okay.
Let me check something else. There's a couple more. Oh yeah, son of a gun. You know what? I wonder if they edited that out because that's not necessarily a standard notation or bracketing. All right, well, I'm a little puzzled, but it doesn't really change anything. It's just I'm just surprised. In any case, to me, this is what I would call a semantic core of the knowledge that, and then in chapter um, let's see, 7, 8. In chapter 8, I showed by using a relational database system with cross references and so forth to show how this equation translates into actual capture of system knowledge.
Okay. This is definitely relevant. For example, perhaps this scheme to Tom's database. I mean, would every entity, person or organization or concept be described with a tuple? Is that just the level of the linking? You just make one of those tuples for each element, each node in the graph.
Yeah, I'm not following you. What tuple are you speaking of?
Okay, so we have equation 4.1 is the category / set theoretic analytical representation of systems.
Right.
Chapter 8 is more like a computer science schema.
Right.
That there's an isomorphism between them.
Right.
About Tom's system, there's different kinds of entities. There's entities and their associations, people, relationship with a book, people with an organization, entities and relationships, and then the views. I believe, if Tom can hear us, can correct us, but I believe Tom has referred to the kind of core as being the entities and their associations. And the views are very relevant, but don't modify the semantic core. I think last time we discussed like how like in about the versioning, we talked about how there could be versioning. There's two kinds of versioning of the semantic core being the actual like no, this person did write this book, is like a knowledge update, versus a view could be proposed, but people can have arbitrary views without changing the semantic core. Tom, are you perhaps back? Oh, don't hear you though. Wait, Tom, I don't hear. Maybe check your microphone or something. Tom, I maybe check your microphone or leave and rejoin, perhaps. I still can't hear you. Tom, perhaps leave and rejoin. Like just close Zoom and rejoin. Because your
Just
audio is
send a chat.
okay.
Well, while we're waiting for that, I
Uh-huh.
just take the situation where you've got the system. The first element there is the set of components, and so with respect to, we can relate that to the idea that the components in this case could be people, authors, people who wrote stuff, and then the subsystem under that, when you recurse down the next level, is all of the things that they wrote. And so we would have a way of tracing that down through a tree. Um, uh, and there are other ways to cross-link it, so that actually you could talk about a network where you've got references in whatever they wrote, they reference other people, and then we have links back to those other people as components.
Tom, Tom, try again. Okay. In the chat, maybe, Tom. Either you can leave it rejoin or you can type it out in the Zoom chat. But is that basically accurate, what George says about the entities, whether it's a person, place, or thing or idea? Like those are just considered entities, and the semantic kernel or semantic model of the database is the nodes and their associations. So it's a relational database, but we still can't hear you. I mean, if it is a relational database, then you explicitly outline that. Okay, correct. A wiki page is like kind of analogous to a view. You could have differently fashioned wiki pages. That also reminds me a lot of FedWiki. Is there a systems representation of FedWiki, George?
I don't know. I was going to, what's his name's meetings,
Ward Cunningham?
Ward, yeah. And sort of participating in that, but at some point, they were spending so much time, it seemed, on the the mechanical details. So, and I tried to use it, and I got a little bit lost in the format of having these columns that jump across and so forth. I think there's a lot of powerful stuff there. I just
Yeah.
never quite got into it myself. But the point of the role of wiki pages or using wikis in this is the notion of augmented data sets. So it's like an extension of the idea of labeling links and nodes in a network. You give them a name and then you augment it with characteristics of whatever that link is supposed to be. If it's a flow, you have a capacity. There's all sorts of things. So a wiki really allows you then to express those things in a text form and a more human readable form that goes beyond the data that's in the database itself.
Yeah. I wonder if it could be said that the analytical representation, you could implement a computational architecture that was entirely centralized.
Hello? Can you
Oh,
hear me
Tom.
by any chance?
Yes. We do now. What did you change? Okay. Go ahead, Tom.
You might
Tom?
not be hearing us.
Tom. We heard you. But you could make this tuple implemented with a totally centralized or federated architecture. And you could even have, in some ways, federation is just centralization everywhere. Like decentralized social media and stuff like that. People think, okay, I'm getting off the banhammer of this or that platform. They jump onto someone's federated server because they heard that, it's a free-for-all, and then just someone arbitrarily bans them there. It's like, but I thought this meant anything went. It's like, no, it just means that there's a more proximal application of moderation. So because a key difference between FedWiki and Wikipedia is not just the pains.
Can you hear me?
Yes, Tom, nice.
Okay, I can hear you too, but both sides have been going in and out for me for some reason. So I just quit and rejoined, and that seemed to fix it. So hopefully it'll stay. So yeah, what you were saying about the semantic model, that was an insight that came to me at one point that seemed important. I think because I was thinking about a, quote, permanent model where you have multiple views of the same data, and the data is only in there one time, so it's easy to change. It's adaptable. So you can have 100 views, 100 diagrams with some element on it, but the element's only defined one place, and each of the diagrams references that one place in the semantic model. So it's adaptable. And the other point about it is you can do multiple views, so you can take different perspectives or different levels of detail. And I find that that's very important. often when you sketch something out, you get a view that's never been viewed before because nobody ever sketched it that way. But it's more than a sketch because it's only referencing anything in the semantic model that presumably is well defined. Does that answer the questions?
Yeah, that's very helpful. Some work that we've done is with reference identifiers. So putting a space between like the row in a table in terms of how to access the information and separating out the reference to the content itself. So for one piece of information, it could say, then go on and look up this row, or it could say, go to this physical location and do this. So that enables a clean articulation of between the underlying data and the views, which also can be data. So they can be like underlying and immutable in one way, or viewed from a view can be an intermediate data type. But I shared, actually, when you first sent the model, some of your earlier emails, I shared that with my colleague RJ, and he pointed out the similarity there. So it's a very modern and we think promising approach that gets off on the right foot with making and yeah, on clarifying what the underlying assertions are, and then which you can make a misleading view. Like it's the truth, but it's not nothing but the truth or whatever. It's just, it can be misleading. A view can be misleading. You can make an optical illusion. But then the provenance of the view is not as up for question within one perimeter.
I think some of this came from my background in software development. I know George has had some as well. And the whole movement towards reuse, which is really about having everything defined once and only once. So you don't have to redefine it. You don't get redundancy in your system. So I worked for a financial company once that had a couple lines of business, and they had developed their own databases, and there was redundant data in multiple databases. So if one line of business changed in a name and address, for example, it didn't necessarily change it every place else. And at night, there would be batch programs running with data going all over the place to try to get things back into sync. So the idea is to organize things so that everything's only defined once. And it seems to me that's very important. There's another other part of different views is some things like parts whole relationship is empirical. There's only one definition or one description of that because it actually exists somewhere. But something like categorization into subtypes can be done in more than one way. So you can subtype automobiles by color, by size, by cost, by type of engine, by number of wheels, 1,000 different ways. You just do the ones that are most useful for you, depending on what you're trying to do. So they can be, you can have multiple views that subtype things in different ways. And I find that's always a problem because everyone subtypes things in a slightly different way. And they assume theirs is the only way. And it's hard to be able to show it multiple times without creating redundancy, which means it's not adaptable and it goes out of style or out of date. So that's a capability that I think we need, but we don't take advantage of because our tools don't support it. But if you do modeling in the right way, you can support it. And that gives us a new capability to try to get where we're trying to get to. I don't know if any of that made
Yeah.
any sense, but
Yeah, one piece I'll add in, another block science related technology is the content addressable transformer CATS. So this is kind of it's actually not the transformer architectures like GPT. This is just more general, like a category theoretic transformation or morphism. And it takes the input, the transformation, the output, and other information, signature or time, and then it makes that its own uniquely hashed slash addressed object. So then what use reuse, so like one level of reuse would be we're gonna show different views on the people at this party. But then the next one would be if one of those views was very computationally intensive and you defined the cat, then that transformation also becomes as uniquely addressable. So then that could be cached or just checked if it were to be rerun or run locally, or it could be output saved. So that is a very synergistic technology with the reference identifiers. They basically require each other. But then the computations can be done in advance. Some computations can be done in advance or checked or done in a zero knowledge way. There's like, so I mean, a big theme, just to kind of state the apparent, is like analytical advances in system science, summarized, synthesized by George, and concordant with analytical advances in like applied category theory, all this. So, and then coming from the computer science and engineering side, a, a lot of refinements and diversification of computer architectures, but that doesn't necessarily mean that it's like a new database structure that's going to be required. Kind of like how Bitcoin could have been developed decades earlier, but it just wasn't like code deployed till it was. So the computational architecture is not necessarily like future ones might do it differently or better, but from this figure, a relational database is all you need to recapitulate the analytical system. That has that's a common understanding in relational graph databases. It is also the essence of both Tom's associative knowledge model and whichever variable is the connections of the system in this equation. So then the two of the directions of travel is sort of analytical playing cleanup, trying to look at what computationally has already been built and just framing it, which probably will not require expanding the bounds of the formalism, but it does require a lot of annotation type work, relatively deep annotation of like a small neighborhood of the graph. And then maybe that would be it. And then after doing a comprehensive annotation, finding an isomorphic total neighborhood between, then maybe it's easy and transferable, or maybe it's not. But either way, that's the kind of work from Tom's work to George's. And then I guess the other way is the sort of like capacity advancement from what is possible with a broader systems view. But there's way more angles to that. That relates to Shingai's work, relates to who knows. Just to sort of summarize those pieces.
I should mention, I bring this up with a little trepidation, that I've really focused on two models. the model that I really wanted to do was a system-oriented view of the cosmos. We've identified lots of different types of systems. There's various people that have put together systems organizations. And I would like to, and we know for systems, you need to understand the whole. I wanted to be able to put these together, do the synthesis, the integration that we need. But to do that, I was studying the systems work that's already been done in the literature and the people and the documents and the ideas, and quotations and so on. So I did that as an initial sort of preliminary model to capture my notes and anybody else's notes that wants to help contribute, and form the basis of doing a more comprehensive, ambitious model. So the second model exists, but it's not in a form where it can be converted to HTML easily. Would take a lot of cleanup, but I have put some parts of it into a PowerPoint. And if we're interested, I can send that out. I have to go back and dig it up, look at it, review it, make sure it's reasonable. But I just wanted you to be aware that there's two. The systems common is fairly basic. There's only maybe 12 or 15 classes, and they're all factual, non-controversial type thing. But one of the things I was trying to do also was to avoid the controversial thing, which form rabbit holes that I would get stuck in, and be able to prove out that I can do a model that's, without getting hung up in big issues about what a system actually is and so on. So I just want you to be aware that there's two separate models. So probably the one that matches better with George's is the second one, not Systems Common. On the other hand, I think Systems Common has provided something useful, and it's shown that this type thing can be done. But yes, it takes a lot of work, and that's one of the issues. And I always see about 15 different directions that I can go, and it's always a problem what to do next.
Roll the die, ask the language model what to do next. Define nodes and edges of the semantic model, identify core information. Fair enough. I think it basically says as much. I don't think this model has the visual input yet, but GPT-4V, which does have visual input, is being rolled out now. So that's going to unlock another big area. But I believe that this is actually just the text. Creating views, exploring different block science work. Reuse as a concept, probably also very compatible with the systems ecology area. Parts whole and categorization. Tom, you mentioned that parts whole is more of like a factuality, but categorization, it's more of a plurality. Two views of the system. The people organizations model, connecting bibliographically to Rob's work with SCA, because that's kind of, those are some of the main things. Like you say there's 12 or 15 types, but like people, publications, organizations, probably some main ones.
Yeah, right.
Yeah. Explore analytical representation, semantic core of the knowledge system. For this, I think we would want to look at the plain text output for one complete item. So if you wanted to prepare that and send it out, like, one person, and one book. And just a minimal text file, just saying, here's a person, birth and death date and all that. They wrote this book. Here's the ISBN.
Okay,
Then
you're saying a text file, not a view.
correct. Just the
So-
semantic core, just the plain text with, 2 to 3 entities and their association. Because if we can describe a person in relationship to a book in an organization, let's just say like 3, or if there's a 4th category that's relevant, like a philosophical school, if we can describe that little system.
Yeah, I have a couple fairly large ones that were experiments, and one is the influence of Henry James that
Oh,
went
great.
through about 5 or 6 generations to Acuff and people that Acuff has trained, and can't remember the names of the other ones, but anyway, but it's a view, but it has text in the view. So that's one of the benefits of this. You can combine text and
Sure.
graphics.
If we can look at that plain text output, and then here is a mapping between natural language and the tuple, the
Yeah.
analytical tuple. But if we can map from source code or structured language output, controlled language output to the tuple, and we can do that for one small or just whatever's available, but a small one, just so we can have an easier kind of checkpoint. Like we don't need to go 6 degrees of influence from Pierce or James or whatever. Just like 2 would be good enough. But if whenever you prepare that, we'll bring it in. If we can highlight, we'll just color the different text in somewhere else in education. Like we defined all the letters. Shingai and George and I have talked about this. So
Okay.
we'll just have the colors, 7 different letters or colors, and just say, if we've accounted for everything between the 2, then we have a clear mapping. Then that's where, again, we could turn back to language model. We could say something like, here's an example of how I'm trying to restructure my data. In this example, the person's name is this, and I want that to be used for the letter C. So just tell it the structure, or use something more syntactic like a regex or another text restructuring approach. Then we could restructure the, Tom's database into basically this data format. Reference IDs as I guess as index, or just as unique identifier, or however that's done, and then just these are the columns.
Excuse me, one of the capabilities of a UML is that every item you have in a UML, I guess it's the modeling tool probably rather than UML, it has a quote documentation section, which you can put text in. And then when you display the element on a view, you can optionally show the documentation or not show the documentation. So again, you can display it in a number of different ways, but you can associate text with the view. Now, I find that useful. Again, you don't want redundancy. So if you have a diagram that shows A has parts B and C, you don't want to say in the documentation for A, it's made up of B and C, because that's already in the model. So I can see there's a progress of initially describing things in general in text, and then gradually converting that to more rigorous definition by using the defined elements of the modeling language. So that's one. So a lot of what I have already has the text, maybe not shown in every view, but shown somewhere. So anyway, I'll send you some examples of what I have, and then you tell me what you think, how it should be changed. I'd mention one other thing as well. I'm sorry to dig into
That's
all
all
these,
good.
but, I have a lot of references, a lot of inclusion in the model by reference. So for example, most of the people have a Wikipedia entry. So I have a reference to the Wikipedia entry, which of course with one click, you can go to Wikipedia. So I don't put anything, or I put very little in the model that's already in the Wikipedia entry because you can easily go to get it there. And it also in some way gets updated, or in some cases gets updated over time. So it's added by reference. I find that's very powerful, but it's a different kind of thing.
Yeah,
And
that makes sense.
it also provides the possibility of broken links. Now, Wikipedia, presumably, once something entry is in there, it's going to be there for a long time. But other places, things are often time out after some period of time. They disappear, or technology gets changed, or something happens and they're gone. So you can't guarantee against broken links.
Yeah, it's more like the index card model than the
Yes.
single source of truth. Yeah, it totally makes sense. Also, isn't this just like wild?
Are you familiar with the people that did index cards way back in the 1920s or 30s? There's a guy spent most of his career doing thousands of index cards in Holland, or
Oh, the Zettelkasten method?
it might have been, yeah.
It's like an index card, little knowledge snippet based approach that is emulated by some digital personal knowledge management tools.
Yeah, I mean, this was long before the computer. But there's people that have had the idea of amassing all the knowledge in some form or another, but not with the technology we have.
I totally agree. I mean, that's that's a big direction, but there are some, I mean, some rate limiting steps are different now. But I mean, just in terms of where we got with notes, no image recognition at all. Actionable, relational, aspirational, logistical for the case of a PhD student. Like without our transcript, without going into other secondary, without doing knowledge, like going into a link or something and downloading and reading a text. So it just shows like how much information is in different things and how rich the out and specific the output can be. And so there's like the stamp collecting entomology angle, the gotta catch 'em all, like all the knowledge. But even enthusiasts of collection understand that it's like not complete. Like Scott David, he says, I have the largest collection of sand. I leave it on the beaches. So
That's a good line.
and people in LLM training spaces are like learning that it's quality over quantity. So structured inputs, natural language, structured language, analytical representations, flexible databases, low code frameworks that help us get pretty far. A lot of great convergences.
So it seems to me there's a set of information that's most useful to understand the cosmos as system oriented. It would include the hierarchy of composition, parts and wholes, and the evolution processes that have taken place over time and continue to take place, and how it all fits together without all the details, because you can't possibly do the details. You can't do the whole cosmos because we can't even see the whole cosmos and never will be able to, as far as we can tell. So part of the challenge is to define what it is that's best, the most useful, and most valuable to collect and integrate, and avoid going down every rat hole, which you can easily spend your whole life doing, and not get together what you need. So there's like a strategy component to this whole thing. I guess we were talking about that a little bit before.
Oh yeah. In the active inference ontology, the thing to focus on is the boundary. And with a comprehensive, formal understanding of boundaries, bulk and boundary objects, we can describe our own sensorium. And then we can consider this question of like what is useful to collect and integrate as a epistemic foraging, hypothesis testing setting. So it goes beyond providing consilience of like parts and wholes, autopoiesis, and so on, helps us turn the microscope / telescope back into the mind, onto the mind. And that's why I think it provides something useful and interesting.
Daniel, is the link that you sent in the emails, is that going to be the one for, see,
For
I'm
education.
I'm on the list for getting the notification to the Google or whatever, the calendar notification for the education meetings.
Okay.
Also Thursdays, but not on this one. But previously, both meetings were on the same link, so I just saved the link.
Yeah, I have changed both, and then I'll there'll also be a little notification for that. But yeah, because I'm no longer with UCD Zoom
Ah, okay.
status.
Yeah, I have ongoing status with the UW because I'm emeritus, so
Nice.
I get
There's
to
no
use it.
postdoc emeritus role.
Yeah, it should be. All
All
right.
right.
Oh,
Any last
could you,
comments?
yeah, could you just make sure I'm on the list of people to get notification for this meeting? Like I say, I get it for the education, but not
Oh.
for this one.
Okay. Yes. Okay. Yes. Any other
Okay.
comments, Tom or Randall? Randall?
No, not really. One thing I just going through my mind is patterns. Not sure how that relates with what you've been talking about for the last hour. Maybe a topic for another day.
Yeah, let's yeah, but because there's probably so much there. Let's for next time, let's patterns in knowledge engineering. All right. Thank you. Farewell,
All right.
everybody.
Yep.
Bye.
Take care.
Thanks.
Bye.